Welcome to Dreaming Through Knowledge, where science becomes calm. Tonight, we are going to tell a story of partnership. We are going to explore the origin of the pale, silent companion that has watched over our world since the beginning of memory. We are going to witness the birth of the moon. But before we travel back to the violent and beautiful dawn of the solar system, I invite you to subscribe to this channel and perhaps leave a comment below. Tell us where you are listening from tonight and what time it is in your part of the world. It is a small way to connect our own locations before we lose ourselves in the deep time of planetary history. Now, let your body settle. Let the gravity of the earth hold you. That pull you feel, the weight of your body pressing into the bed, is a constant. But tonight, we are going to a time when that gravity was the only thing holding a liquid world together. We are traveling back 4.5 billion years. To understand the moon, we must first understand the earth before the moon. We must erase the silver light from the night sky. We must erase the tides that rise and fall with gentle regularity. We must erase the stable seasons. We are going to a lonely, chaotic, and terrifyingly beautiful place, the Hadean Earth. We find ourselves floating in space, looking down at our home. But it is not the blue marble we know. There are no white swirls of clouds. There are no green forests. There are no blue oceans. In fact, there is no solid ground at all. The Earth is a ball of fire. It is a sphere of molten rock glowing with a dull, angry red light against the black backdrop of the stars. It looks less like a planet and more like a failed star. It is radiating heat into the vacuum, a dying ember in the cold. This is the magma ocean. The entire surface of the planet is liquid. It is a sea of silicate rock, heated to 2,000 degrees Celsius. It churns and roils, driven by convection currents from the deep interior. Giant bubbles of gas, steam, carbon dioxide, sulfur rise to the surface and burst, sending sprays of lava kilometers into the sky. Why is it so hot? Because the Earth has just been born. It was formed from the violent collision of billions of asteroids and planetesimals. Every rock that slammed into the young Earth delivered its energy as heat. The kinetic energy of the impact was converted instantly into thermal energy. The planet was forged in a bombardment. And inside, deep in the core, radioactive elements are decaying. Uranium, potassium, and thorium are breaking down, releasing high-energy particles that heat the rock from within. The Earth is being cooked from the outside by impacts, and from the inside by radiation. It has no choice but to melt. In this liquid state, a profound reorganization is taking place. It is called differentiation. Imagine a jar of salad dressing, oil and vinegar mixed together. If you shake it, it becomes cloudy. But if you let it sit, the heavier liquid sinks and the lighter liquid floats. The same thing is happening to the Earth. The Earth is a mixture of rock and metal. The metal, mostly iron and nickel, is heavy. In the liquid magma ocean, the iron droplets begin to sink. They fall like rain through the molten stone. They gather in streams, then rivers, flowing downward toward the center of gravity. Billions of tons of molten iron rush to the center of the planet. This event, the iron catastrophe, is the most significant geological event in Earth's history. It created the core. As the iron sank, it displaced the lighter rock, the silicates, the magnesium, the aluminum. These materials floated upward, they formed a scum on the surface of the magma ocean. This scum would eventually cool to become the crust. Attachment. Attachment. So, even in this chaos, there is order emerging. The Earth is sorting itself out. Core, mantle, crust. The structure of the planet is being defined by gravity and density. But look up. Look at the sky above this molten world. It is not the clear, transparent sky we know. It is a heavy, oppressive blanket. The volcanoes and the bubbling magma are releasing vast amounts of gas. The atmosphere is thick with steam. It is hundreds of times denser than the air today. The pressure at the surface would crush a submarine. This atmosphere acts like a greenhouse. It traps the heat of the magma ocean, preventing it from radiating away into space. It keeps the planet molten. It is a suffocating embrace, and the sky is busy. The solar system is young. It is still under construction. The space between the planets is not empty. It is filled with debris, leftover bricks from the building of the worlds. Asteroids, ranging from the size of pebbles to the size of mountains, drift through the dark. Occasionally, one of them crosses the path of the Earth. We see a flash in the upper atmosphere, a streak of light, then a silent impact on the magma ocean, a splash, a ripple of fire spreading out in circles. The Earth is eating. It is sweeping up the crumbs of the solar nebula. But the most striking thing about this young Earth is not the heat or the atmosphere or the impacts. It is the loneliness. Look for the moon. It is not there. The night sky is empty of the large white face we are used to. There is no companion to watch over the darkness. There is no man in the moon. There are only the distant stars, cold and unblinking. Without the moon, the Earth is different in a fundamental way. It spins differently. Today, the Earth rotates once every 24 hours. This rhythm feels natural to us, but 4.5 billion years ago, the Earth was spinning much, much faster. A day on the Hadean Earth lasted only 6 hours. The sun would rise, race across the sky in 3 hours, and set. 3 hours of darkness, and then sunrise again. The planet was spinning like a top. This rapid rotation had consequences. The centrifugal force flattened the Earth. It bulged at the equator. It was not a sphere. It was an oblate spheroid, squashed by its own speed. And the winds. The atmosphere, whipped by the fast rotation and heated by the lava below, moved in ferocious bands. Super hurricanes raged across the molten surface, storms that lasted for centuries, driven by the heat of the ground rather than the sun. There were no tides, or rather, there were only solar tides. The gravity of the distant sun pulled on the magma ocean, creating a small bulge that traveled around the planet. But it was weak. The magma rose and fell only a few meters. It was a gentle pulsing compared to the tides we know today. This lonely, spinning world seems stable. It seems like it could continue this way forever, cooling slowly, forming a crust, eventually becoming a quiet, solitary planet like Venus or Mars. But the solar system is not empty, and the Earth is not the only object growing in this orbit. To understand what is coming, we must look at the neighborhood. We must look at the Lagrange points. In the dance of gravity between the Sun and the Earth, there are stable spots, eddies in the gravitational river, places where an object can park and remain stable. One of these spots, L4 or L5, lies 60 degrees ahead of the Earth in its orbit or 60 degrees behind. In one of these quiet corners, dust began to gather. Just as the Earth accreted from the solar nebula, another body began to form in the Earth's shadow. It grew from a pebble to a boulder, from a boulder to a planetesimal, from a planetesimal to a protoplanet. It ate the dust that Earth missed. It grew fat on the leftovers. Astronomers have given this lost world a name. They call it Theia, named after the Titan in Greek mythology who gave birth to Selene, the moon goddess. For millions of years, Theia and Earth coexisted. They drifted around the sun in lockstep, separated by millions of kilometers, sisters in the dark. Theia grew to be the size of Mars, about half the size of Earth. It developed its own iron core, its own mantle, its own crust. But gravity is a harsh master. As Theia grew massive, its orbit became unstable. It became too heavy for the delicate balance of the Lagrange point. It began to wobble. It drifted forward and backward. It oscillated. Like a marble rolling in a bowl, it swung higher and higher up the sides. On the Earth, looking up into the night sky, you might have seen it. A wandering star. A bright, reddish point of light that moved differently from the others. A star that grew brighter every century. It was not a threat yet. It was a curiosity, a companion. But the mathematics of chaos dictated that this stability could not last. The wobble increased. Theia began to leave its safe harbor. It began to drift toward the Earth. Imagine the tension of this approach. Two planets sharing the same lane on the cosmic highway, one massive, one smaller, both moving at 30 kilometers per second around the sun. The approach was slow. It took millions of years for the orbits to align. It was a gravitational dance, a slow-motion waltz of doom. But for now, let us stay with the Earth, the innocent victim. The cooling has continued. Patches of black crust have begun to form on the magma ocean. Like ice flows on a winter river, rafts of solid basalt drift on the surface. They collide and sink, remelting in the depths. The Earth is trying to build a skin. It is trying to seal itself off from space. The first solid ground in history is forming. If you stood on one of these rafts, the heat would be intense. The rock beneath your feet would be hot enough to fry an egg. The air would be unbreathable, toxic with carbon dioxide and acid. But you would see the stars, and among them you would see Theia. It is now a disk, not a point. It is a small red moon in the sky, getting larger every night. The gravity of Theia begins to pull on the Earth. It raises tides in the magma ocean. The liquid rock heaves and sighs as the visitor approaches. The Earth groans under the strain. This is the moment before the change, the calm before the cataclysm. The Earth is a solitary world, spinning fast, wrapped in steam, unaware that its loneliness is about to end in the most violent way possible. In the next chapter, we will watch the dance of approach. We will see Theia grow from a star to a planet in the sky. We will explore the physics of the orbital mechanics, the horseshoe orbits, and the chaotic drift. We will see how two worlds can share the same space without touching until they can't. We will feel the anticipation of the collision, the moment when the sky is filled with another world. But for now, rest in the solitude of the Hadean Earth. Float above the red and black surface. Watch the magma currents swirl in lazy spirals. The planet is whole. It is complete. It is alone. Feel the rapid spin, the 6-hour day flashing by. Sunrise, sunset, sunrise, sunset. A strobe light of days. Drift in the heat of the young world. You are safe here, suspended in the deep time before the impact. The moon is just a dream waiting to be born. We have witnessed the lonely, molten Earth spinning in the dark, a world of fire and steam isolated in its orbit. But as we learned, it was not truly alone. For millions of years, a companion had been growing in the shadows, a planet named Theia. Now, we must watch the dance begin. This is not a sudden event. In the clockwork of the solar system, nothing happens quickly. The approach of Theia toward Earth was a slow, graceful, and terrifying waltz that played out over eons. To understand this dance, we must look at the geometry of gravity. We often think of orbits as simple circles, lanes on a highway where cars stay in their lines. But gravity is more subtle than that. There are pockets of stability in the void. In the orbital path of any planet around the Sun, there are 5 specific points where the gravity of the planet and the gravity of the Sun cancel each other out. These are the Lagrange points. They are gravitational eddies, places where dust and rocks can drift and accumulate, protected from the tug of the rest of the system. Theia was born in one of these points, L5. It sat 60 degrees behind the Earth, trailing us in our orbit like a ghost. For millions of years, it was a stable arrangement. Earth moved. Theia moved. They traced the same path around the Sun, separated by a fixed distance of 150 million kilometers. Imagine standing on the magma ocean of the Hadean Earth, looking up at the night sky. You would see the stars. You would see the wandering planets, Jupiter, Mars. But if you looked carefully, you would see a bright, unblinking light following the ecliptic, a light that never moved relative to the other planets, a constant companion. At first, Theia was small, an asteroid, then a moon-sized object, then a planet. As it grew, it began to consume the dust and debris in its own Lagrange point. It cleared its neighborhood. It grew to the size of Mars. But mass changes everything. As Theia grew heavier, its relationship with gravity changed. It became too big for the safe harbor of L5. The pocket of stability was shallow, and Theia was filling it to the brim. The gravitational nudges from Venus and Jupiter began to affect it. The orbit began to jitter. Theia started to wobble. This wobble is known as libration. Instead of sitting perfectly still in the Lagrange point, Theia began to drift forward and backward, tracing a slow loop around the stable point. Like a marble rolling around the bottom of a bowl, it moved higher and higher up the sides. From Earth, the wandering star would have started to behave strangely. It would get brighter for a few centuries, then dimmer. It was oscillating. It was testing the boundaries of its cage. And then, inevitably, the marble rolled over the edge. Theia escaped the Lagrange point. It began to drift freely along the Earth's orbit. This initiated a rare and beautiful orbital dance called a horseshoe orbit. When 2 planets share an orbit, they engage in a game of gravitational tag. As Theia drifted toward Earth, it didn't just crash immediately. The mechanics are counterintuitive. As Theia approached Earth from behind, Earth's gravity pulled on it. You might think this would speed Theia up and make it crash faster. But in orbital mechanics, if you speed up, you move into a higher orbit. So, as Earth pulled Theia, Theia sped up, moved into a higher, wider orbit, and slowed down relative to Earth. It fell behind. It drifted away. Then, years later, Theia would catch up from the other side. Earth's gravity would pull it back. This would slow Theia down. But slowing down makes you drop into a lower, faster orbit. so Theia would speed up and move away again. For thousands of years, the two planets traced a horseshoe shape relative to each other, coming close, then retreating, then coming close again. It was a flirtation, a gravitational breathing, but the solar system is not a perfect vacuum. There is drag, there are tides. The chaos of the other planets tugged at the pair. Each encounter brought them slightly closer. The horseshoe loop tightened. The dance became intimate. Now, let us return to the surface of the Earth. The time is approaching. The sky has changed. The wandering star is no longer a point of light. It is a disk. It is a second moon, but redder, darker, and ominous. It grows larger every night. The tides on the magma ocean are going wild. The gravity of the approaching planet is raising waves of molten rock hundreds of meters high. The crust cracks and groans. Volcanoes erupt simultaneously across the globe, triggered by the tidal stress. The Earth is screaming. The animals, if there were any, would have gone silent. The atmosphere, thick with steam, would be swirling in violent storms driven by the gravitational heat. And then the final approach begins. Theia is no longer oscillating, it is falling. It fills the sky. It is a world of its own. We can see its craters. Its lava sees its own black clouds. We can see the face of the destroyer. It is coming in at an angle. It is not a head-on collision, which would shatter both worlds into dust. It is a glancing blow, a sideswipe. The speed of the impact is relatively slow, about 40,000 kilometers per hour. This is slow for cosmic collisions, but it is fast enough to liquefy rock instantly. The moment of contact is silent, for there is no air in space to carry the sound between the worlds. But the moment the atmospheres touch, the sky ignites. The friction of two atmospheres colliding creates a shock wave of plasma that wraps around both planets. Then the rocks touch. The crust of Earth bends, then breaks, then melts. The crust of Theia shatters. The mantle of Theia, the rock layer beneath the crust, strips off like the skin of an orange. It vaporizes. A spray of molten rock, billions of tons of it, jets outward into space. It fans out like a splash of water, but the water is lava. This is the ejecta curtain. The core of Theia, a dense ball of iron, does not stop. It punches through the Earth's mantle. It dives deep. It sinks through the molten rock of our planet like a bullet through water. It spirals down and merges with the Earth's core. The heart of the visitor is swallowed by the host. The Earth gains mass. It gains gravity. It gains the iron that will one day generate its magnetic field. Attachment is zero attachment. But the rest of Theia, the mantle, the crust, and a huge chunk of Earth's own upper layers is flung into orbit. The energy of the impact is sufficient to melt the entire Earth again. Any crust that had formed is destroyed. The planet becomes a global droplet of magma, deformed into a pear shape by the blow. It wobbles in space, a bell struck by a hammer. Around the Earth, a ring forms. It is not a polite ring of dust like Saturn's. It is a ring of fire. It is a torus of vaporized rock, gas, and lava droplets spinning wildly around the equator. It is massive. The amount of material in the ring is equal to the mass of the moon. It is incredibly hot, 4,000 degrees. It glows with a blinding white light. If you stood on the surface of the Earth now, which you couldn't because it is magma, you would see an arch of fire spanning the sky, brighter than the sun. There is no night. The ring illuminates the dark side of the Earth with the intensity of 1,000 noons. This ring is the womb of the moon. Inside this swirling inferno, the physics of accretion begins again. The rock vapor cools. It condenses into droplets of lava. The droplets stick together to form clumps. The clumps form moonlets. It is a chaotic environment. The moonlets smash into each other, merging and breaking, but gravity favors the largest. One seed grows bigger than the rest. It sweeps up the material in the ring. It eats its siblings. It grows at a terrifying rate. Computer simulations show that the moon may have formed in less than 100 years. Some models suggest it formed in mere months. It was a flash birth. One moment a ring of fire, the next a glowing sphere. The new moon was huge in the sky. It formed very close to the Earth, just beyond the Roche limit, the distance where tidal forces would tear it apart. It was perhaps 20,000 kilometers away. Today, the moon is 400,000 kilometers away. Imagine a moon 20 times larger in the sky. Imagine the heat radiating from it. The Earth and the moon were a double planet system, both glowing red, locked in a gravitational embrace. They were spinning rapidly. The Earth's day was 5 hours long. The moon orbited every few hours. It was a dizzying, frantic partner dance. But the collision had done something else. It had knocked the Earth over. Before Theia, the Earth likely spun upright, with its axis perpendicular to its orbit. But the impact tilted the planet. It knocked it over by 23.5 degrees. This tilt is the reason we have seasons. It is the reason we have winter and summer. It is the reason life on Earth is driven by cycles of change. The collision broke the symmetry of the world and gave us the rhythm of the year. We are living in the aftermath of the crash. The chemistry of the moon tells the story of this violence. When astronauts brought back rocks from the moon, scientists analyzed them. They found that the oxygen isotopes, the chemical fingerprint of the moon, were identical to the Earth. This was a shock. Every other body in the solar system has a unique fingerprint. Mars is different, meteorites are different, but the moon and Earth are twins. This proved that the moon was not a captured asteroid. It was not a stranger. It was made of Earth. It was flesh of our flesh, rock of our rock. Theia and Earth had mixed so thoroughly in the explosion that they became one substance. The moon is the splash that never fell back. However, there is a difference. The moon is dry. It has almost no water and very little iron. Why? Because the iron sank to Earth's core during the impact, and the water vaporized and was lost to space in the heat of the explosion. The moon is the distilled essence of the Earth's crust, baked dry, stripped of metal, and recast in the vacuum. As the new moon coalesced, it was molten. A lunar magma ocean covered its surface. It shone like a second sun. But because it is small, it cooled fast. A crust of white anorthosite rock floated to the surface of the lunar magma ocean. This is the bright white rock we see when we look at the moon today, the lunar highlands. It is the foam of the ancient melt. The dark patches, the maria or seas, formed much later from volcanic eruptions. But the white face of the moon is the original skin formed in the weeks after the giant impact. Let us hover now in the space between the two worlds. The violence has settled into a steady orbit. The ring is gone, swept up by the moon. We have two hot, glowing spheres circling each other in the dark. They are tidally locked. The heavy side of the moon faces the Earth, and it will never turn away. The man in the moon is born, staring eternally at his parent. The view is spectacular. The Earth is a swirling marble of red lava and black clouds spanning 40 degrees of the lunar sky. The moon is a smaller, whiter ember. There is a silence in space, but gravity is shouting. The tides are kneading the worlds, keeping them warm. The relationship has begun. In the next chapter, we will watch them drift apart. We will explore the physics of tidal recession. We will see how the moon steals energy from the Earth's spin to boost itself into a higher orbit. We will see the Earth slow down, the days lengthening from 5 hours to 24. We will see how the moon stabilized the Earth's wobble, preventing the climate from flipping into chaos. We will understand why the moon is the anchor that makes life possible. But for now, feel the tension of the new orbit, the balance between the fall and the escape. The visitor has become the companion. The collision has become the dance. The two worlds are linked forever in the dark. Rest in the gravity of that bond. The collision is over. The shock wave has circled the globe. The invader, Theia, has been destroyed, its iron heart swallowed by the Earth, its rocky flesh scattered into the void. Silence returns to the solar system, but it is a silence heavy with heat. The Earth is no longer a solitary sphere moving through the dark. It is the center of a chaotic, glowing system. Surrounding our planet is a structure of terrifying beauty. A ring. It is not the icy, delicate ring of Saturn, made of frozen water and dust. It is a ring of fire. It is a torus of vaporized rock, molten glass and gas, spinning wildly around the equator. It glows with a blinding, white-hot intensity, illuminating the night side of the Earth with the brightness of 1,000 noons. If you were to stand on the surface of the Earth, which is currently a roiling ocean of lava, and look up, the sky would be bisected by this arch of light. It spans from horizon to horizon, a bridge of burning debris. It is so hot that it vaporizes any meteor that tries to pass through it. It is a shield of plasma. Inside this ring, the laws of physics are working to build a new world. The material is moving at orbital speeds, thousands of kilometers per hour. But it is also cooling. The vacuum of space is cold. As the rock vapor radiates its heat away, it begins to condense. It rains. But it does not rain water. It rains liquid rock. Droplets of olivine and pyroxene condense out of the gas cloud. They clump together, sticky with heat. Tiny grains become pebbles. Pebbles become boulders. Boulders become mountains floating in the stream. This is accretion happening at a feverish pace. In the solar nebula, it took millions of years to build a planet. Here, in the dense wreckage of the collision, it happens in a flash. Computer simulations suggest that the moon may have formed in less than 100 years. Some models say it could have happened in mere months. It was a violent birth. The mountains smashed into each other, merging, growing larger, sweeping up the smaller droplets. Gravity was the selector. The largest clumps had the strongest pull. They ate their neighbors. But there was a boundary they could not cross, the Roche limit. Gravity works in two ways. It pulls things together, but it also tears things apart. If a satellite gets too close to the planet it orbits, the planet's gravity pulls much harder on the front of the satellite than on the back. This difference, the tidal force, stretches the object. If it gets too close, it rips apart. Inside the Roche limit, no moon can exist. The debris stays as a ring. But outside the limit, gravity is gentle enough for a moon to hold itself. Together, the material of the ring spread outward. As it crossed this invisible line, the chaos organized itself. A single seed, a dominant clump of rock, began to dominate the outer edge of the disk. It was the embryo of the moon. It swept up the ring. It acted like a vacuum cleaner, clearing its orbit. The arch of fire thinned out, its material falling onto the growing sphere. And there, hanging in the sky, was the new world. It was huge. The moon formed very close to the Earth, perhaps only 20,000 kilometers away. Today, it is 400,000 kilometers away. Imagine a moon appearing 20 times larger in the sky than the one we know. It was a terrifying object. It was molten. The heat of the accretion had melted it completely. It was a sphere of magma, glowing dull red, pulsating with tides raised by the Earth. It looked like a giant, unblinking eye staring down at its parent. For a brief time, the Earth and the Moon were a double planet. Two hot embers spinning in the dark, locked in a gravitational embrace. The heat radiating from the Earth kept the face of the Moon molten. The heat radiating from the Moon kept the Earth's crust from freezing. They kept each other warm in the cold of the Hadean night. But the Moon was different from the Earth. The chemistry that tells the story. The collision had been so violent that it vaporized the volatile elements. Water, nitrogen, carbon dioxide. These light molecules boiled away into space. They escaped the weak gravity of the ring. What was left was the refractory material, the stuff that is hard to melt. Calcium, aluminum, titanium, silicon. The Moon is a dry world. It is a distilled world. It is the Earth, stripped of its ocean and its air, reduced to its mineral essence. It also lacks a large iron core. The iron from Theia had sunk into the Earth. The Moon was built from the mantle, the rocky outer layers. Because of this, the Moon is lighter than the Earth. It is less dense. It has only a tiny, weak heart of metal. As the Moon hung there, glowing red, it began to cool. Space is a good insulator, but it is also infinite. The heat radiated away. The surface of the Moon, the lunar magma ocean, began to crystallize. But unlike the Earth, where the crust is constantly recycled by plate tectonics, the Moon's crust formed once and stayed. As the magma cooled, minerals began to precipitate. Heavy minerals like olivine sank to the bottom of the magma ocean. But light minerals, specifically a type of feldspar called anorthosite, floated. Imagine icebergs floating on a sea of water. On the Moon, it was icebergs of white rock floating on a sea of black magma. These crystals of anorthosite rose to the surface. They gathered together. They formed a skin. This skin is the lunar highlands. When you look at the Moon today, the bright white parts are this ancient crust. It is the original rock foam that floated to the top 4.5 billion years ago. It is the oldest surface we can see with the naked eye. The dark patches, the man in the Moon, are younger. They are lava flows that erupted later, filling in the lowlands, but the white mountains are the primordial skin. As the crust hardened, the Moon became a solid object, but it was not static. It was locked in a ferocious interaction with the Earth. Tides, gravity falls off with distance. The side of the moon facing the Earth feels a stronger pull than the side facing away. This difference stretches the moon. It pulls it into the shape of a football or a lemon. When the moon was molten, this stretching was easy. The liquid rock rose and fell in waves, but as it solidified, the stretching created friction. It created heat. The moon groaned under the stress. This friction acted as a brake. The moon was spinning on its axis, but the Earth's gravity dragged on the bulge, slowing the spin down. Over millions of years, the moon's rotation slowed. It spun slower and slower until its rotation period exactly matched its orbital period. This is tidal locking. The moment it happened, the moon froze in its orientation. One face, the heavy face, the face with the bulge, was locked toward the Earth forever. The other face, the far side, was turned away, destined to stare eternally into the deep space. The man in the moon was born. He has been staring at us for 4 billion years. He watched the oceans form. He watched the continents drift. He watched the dinosaurs rise and fall. He watched us build cities. He has never blinked. But the interaction went both ways. The moon also raised tides on the Earth. The Earth was spinning fast, a 5-hour day. The moon was close. The tides were monstrous. Not tides of water, there were no oceans yet, but tides of magma. The ground rose and fell by kilometers every few hours. This constant kneading kept the Earth hot. It delayed the formation of a solid crust on our world. The moon was a heater, orbiting the Earth, massaging the planet with gravity. But there is a rule in physics: conservation of angular momentum. The Earth was spinning faster than the moon orbited. The tidal bulge on O. The Earth was carried ahead of the moon by the planet's rapid rotation. This bulge pulled the moon forward. It gave the moon a gravitational kick. It added energy to the moon's orbit. And when you add energy to an orbit, the object moves outward. It spirals away. The moon began to retreat. It started its long, slow journey away from its parent. Year by year, century by century, the moon grew smaller in the sky. The tides grew weaker. The violence subsided. This retreat is still happening today. The moon moves away from us at a rate of 3.8 centimeters per year, about the speed that fingernails grow. It is a slow goodbye that has lasted for eons. But in those early days, the retreat was faster. As the moon moved away, the Earth slowed down. The energy gained by the moon was stolen from the Earth's spin. The day lengthened. 5 hours became 6, then 8, then 10. The frantic strobe light of the Hadean day slowed into a rhythm that life could eventually endure. While this dance continued, the solar system was cleaning itself up. The debris from the collision, the material that didn't make it into the moon or fall back to Earth, was ejected. Some of it hit Venus, some of it fell into the sun, but much of it was thrown out into the deep cold. The neighborhood was being swept. The moon, now a solid white sphere, became a shield. As comets and asteroids rushed toward the inner solar system, drawn by the sun, many of them hit the moon instead of the Earth. The craters we see today, Tycho, Copernicus, Kepler, are the scars of this protection. The moon took the blows for us. It recorded the history of the violence that Earth has largely erased through erosion and tectonics. The face of the moon is a history book of the solar system. But the moon did more than just block rocks. It stabilized the Earth. A spinning planet is like a top. If it spins fast, it is stable. But if it slows down, or if it is hit by something, it wobbles. The axis tilts. Mars has no large moon. Its axis wobbles wildly over millions of years. Sometimes it is upright. Sometimes it leans over on its side. This causes chaotic climate swings. The poles melt. The equator freezes. It is a planet of extremes. Earth has the moon. The moon is large, unusually large for a planet our size. Its gravity acts as an anchor. It holds the Earth's tilt steady at 23.5 degrees. It limits the wobble. It ensures that the seasons are regular. It ensures that the summer is never too hot and the winter never too cold. It created the climate stability that allowed life to evolve over billions of years. Without the moon, the Earth might have been a chaotic world of shifting ice caps and boiling tropics, unable to support complex civilizations. We owe our stability to the silent watchman. As the moon cooled, its internal fire died. It is too small to hold on to its heat. The volcanoes stopped. The magma ocean solidified. The atmosphere, if it ever had a wisp of one, drifted away. It became a dead world, a geologically silent rock, a mirror reflecting the light of the sun. But its influence on Earth was just beginning. The water arrived on Earth, delivered by comets. The magma ocean of Earth cooled into a crust. The first oceans formed, and the moon grabbed them. The tides shifted from magma to water. The moon pulled the liquid shell of the Earth. It created the intertidal zone, the mixing pot of the shore, the place where the water meets the land. Many scientists believe this is where life began, in the rhythm of the tide, wet, then dry, wet, then dry, concentrating chemicals, encouraging reactions, the heartbeat of the ocean, driven by the ghost of Theia. In the next chapter, we will explore this relationship further. We will look at the late heavy bombardment. We will see how the moon's face was painted with the dark Maria, seas of lava that erupted billions of years after its formation, filling the giant impact basins. We will understand why the man in the moon looks the way he does. We will look at the eclipse, the cosmic coincidence that makes the moon and the sun appear exactly the same size in our sky, allowing us to see the sun's corona. But for now, imagine the young moon, a white, glowing pearl huge in the night sky, casting sharp shadows on the black rocks of the barren Earth. It is the first night, the first time the Earth has a lantern. The fear of the total dark is gone. Rest in the light of that silver companion. It is watching. It is holding the Earth steady. It is keeping the rhythm. The moon has formed. It has coalesced from the ring of fire, cooled from a magma ocean, and locked its face toward the Earth. It hangs in the sky, a pristine white sphere of an orthosite rock. It is silent. It is still, but the solar system is not yet at peace. We are about 4 billion years ago. The major planets have formed, but their orbits are not yet stable. The giant planets, Jupiter, Saturn, Uranus, and Neptune, are restless. They are interacting with a vast disk of icy debris that lies beyond them. This debris field is the leftover scaffolding of the solar system. It contains trillions of comets and asteroids. As the giant planets migrate, their gravity disturbs this field. They scatter the debris. They throw it inward. This triggers one of the most violent epochs in the history of our corner of the galaxy, the late heavy bombardment. The inner solar system turns into a shooting gallery, Millions of rocks, ranging from the size of a house to the size of a city, come hurtling toward the Earth and the Moon. They are traveling at speeds of up to 70 kilometers per second. The Earth, being larger, takes the brunt of the assault, but the Earth is active. Its crust is recycling. Its wind and water erode the scars. The evidence is hidden. But the Moon remembers. The Moon has no atmosphere to burn up the incoming rocks. It has no wind to weather the craters. It has no plate tectonics to subduct the crust. It is a perfect, immutable record. Let us watch a single impact. An asteroid, 10 kilometers wide, the size of the mountain that killed the dinosaurs, slams into the lunar surface. The impact is silent, for there is no air to carry the sound. But the release of energy is cataclysmic. It is equivalent to millions of nuclear weapons detonating at once. The asteroid penetrates deep into the crust. It vaporizes instantly. The rock of the Moon behaves like a liquid under the intense pressure. It ripples. A shock wave travels through the ground, lifting the crust and throwing it outward in a perfect circle. A crater is formed, a bowl-shaped depression tens of kilometers wide. In the center, the rock rebounds, rising up like a splash of water frozen in stone. This creates the central peak that we see in many large craters. The debris from the impact, the ejecta, flies outward. It rains down across the lunar surface, creating secondary craters, rays of white dust that stretch for hundreds of kilometers. During the late heavy bombardment, this happened not once, but thousands of times. The face of the Moon was pulverized. The smooth white crust was shattered into a chaotic landscape of overlapping holes. Some impacts were so large they cracked the crust all the way down to the mantle. These created the impact basins: Imbrium, Serenitatis, Crisium. These are scars thousands of kilometers across. When these basins formed, they were deep holes, but they didn't stay empty. The Moon still had a molten heart. Deep below the crust, pockets of radioactive elements, uranium, thorium, were heating the rock. The mantle melted. Magma formed. Attachment 0. Attachment. This magma was different from the original magma ocean. It was basalt, dark, iron-rich lava, similar to the lava of Hawaii. The impact basins had thinned the crust above these magma pockets. The cracks created by the asteroids acted as plumbing. The lava found a way up. It flooded the basins. Imagine standing on the edge of the Imbrium Basin 3 billion years ago. You would see a sea of fire, a vast lake of black lava filling the crater from rim to rim. It flowed smoothly, burying the smaller craters, smoothing out the floor. It took millions of years for these seas to cool. When they did, they turned into flat, dark plains of rock. These are the Maria, Latin for seas. When you look at the Moon tonight, the dark patches that make up the face of the man in the Moon are not shadows. They are frozen lava flows. They are the healed wounds of the bombardment. Interestingly, almost all the Maria are on the near side of the Moon, the side facing Earth. The far side is almost completely white, covered in craters but very few lava seas. Why? Gravity. The Earth's gravity pulls on the Moon's crust. It made the crust on the near side thinner, easier to break. The crust on the far side is thicker, harder to puncture. So the lava only bled out on the side facing us. The Moon shows us its scars. This bombardment was destructive, but it was also a gift. Many of the impactors were not asteroids, rock, but comets, ice. They came from the outer solar system, from the region of Jupiter and Saturn. they were dirty snowballs. When they hit the moon, the water vaporized. Most of it was lost to space, but some of it, a tiny fraction, found a hiding place. At the poles of the moon, there are craters that are so deep, their floors never see sunlight. They are in eternal darkness. The temperature there is incredibly low, minus 240 degrees Celsius. It is colder than Pluto, pitch 1%. When a water molecule hops into one of these cold traps, it freezes. It never sublimates. It stays there forever. Over billions of years, comet after comet delivered water. The cold traps filled up. Today, we know there are billions of tons of water ice hidden in the shadows of the lunar poles. This is a legacy of the bombardment. It is a reservoir of resources for future explorers. The violence of the past has provided the fuel for the future. But the bombardment did something even more important for Earth. It delivered the volatiles. The Earth formed hot and dry. The water that fills our oceans today was largely delivered by this late rain of comets and asteroids, the late veneer. If the giant planets hadn't migrated, if they hadn't scattered the comets inward, Earth might be a dry desert world. We owe our oceans to the chaos of the outer solar system. We owe our life to the rocks that fell from the sky. Eventually, the bombardment slowed. The debris was cleared. The planets settled into stable orbits. The solar system became quiet. The moon cooled completely. Its volcanoes went extinct. It became a geologically dead world, a museum piece, but it continued to retreat. The tides pushed it further away. As it moved, its influence on Earth changed. In the beginning, the tides were massive and frequent. As the moon moved away, the tides became gentler. They created the intertidal zones, the rhythm of the shore. This rhythm may have been the catalyst for life. The wet-dry cycle in tidal pools concentrates chemicals. It encourages the formation of RNA and DNA. The moon acted as a mixer for the primordial soup. And it stabilized the climate. Without the moon, Earth's axis would wobble wildly, like a dying top. The poles would drift to the equator. The climate would swing from ice age to hothouse in a few thousand years. Life would struggle to adapt. But the moon's gravity holds us steady. It keeps the tilt at 23.5 degrees. It gives us predictable seasons. It gives us the stability we need for long-term evolution. The moon is the anchor of the biosphere. Now, imagine the view from Earth about 3 billion years ago. The bombardment is over. The moon is still closer than today, but receding. It is fully formed. The white highlands and the dark Maria are visible. The face is familiar. The Earth is blue. The oceans have formed. The first continents of granite are rising. The atmosphere is clearing. Simple life, bacteria, is already teeming in the water. The moonrise is a spectacular event. It is brighter than today. It illuminates the primitive Earth with a silver glow. It pulls the tides, mixing the nutrients in the sea. It is a partner, a silent guardian. In the next chapter, we will look at a specific phenomenon that links these two worlds in a cosmic coincidence: the eclipse. We will explore why the moon and the sun appear to be exactly the same size in our sky. We will look at the Saros cycle, the clockwork rhythm of shadows. We will see how eclipses have terrified and inspired humanity. And we will realize that this spectacle is temporary. As the moon moves away, there will come a day when it is too small to cover the sun. We are living in the only time in history when a total eclipse is possible. But for now, let us stand on the rim of a lunar crater. Look out over the sea of lava. It is solid rock now, smooth and dark. Look up at the Earth hanging in the black sky. It is blue and white and beautiful. It is the only thing that moves in the lunar sky. Feel the silence. The vacuum preserves the history. The footprints of the bombardment are still fresh, billions of years later. Rest in the stillness of the stone. The violence has passed. The peace remains. We have stood on the rim of the battered lunar craters. We have seen the fires of the formation and the scars of the bombardment. But the relationship between the Earth and the Moon is not static. It is a dynamic, evolving dance. It is a relationship defined by motion, by energy transfer, and by the slow, relentless stretching of time. When the Moon first coalesced from the debris of the ring, it was a terrifying neighbor. It hung in the sky, 20 times larger than it appears today. It orbited the Earth once every few hours, racing across the heavens with a speed that would have made the stars seem to spin. The Earth, too, was spinning wildly, with a day that lasted only 5 or 6 hours. It was a frantic system, possessing too much energy to remain calm. Over the last 4 billion years, this energy has been bled away. The Moon has drifted outward. The Earth has slowed down. This process is called tidal recession. It is the mechanism that tamed our world. To understand it, we must look at the water. The gravity of the Moon pulls on the Earth, but it does not pull evenly. It pulls hardest on the side facing the Moon and weakest on the side facing away. This differential pull stretches the Earth. It pulls the solid rock up by about 30 centimeters, but it pulls the liquid water of the oceans up by meters. This creates a bulge of water, the high tide. Because the Earth rotates underneath the Moon, this bulge travels around the planet. It is a wave that never breaks, constantly chasing the position of the satellite. But there is a catch. The Earth spins faster than the Moon orbits. The friction of the spinning Earth drags the tidal bulge forward. It pushes the high water slightly ahead of the Moon. This misalignment has a profound gravitational consequence. The bulge of water has mass. Because it is ahead of the Moon, its gravity pulls the Moon forward. It gives the Moon a gravitational kick, constantly adding energy to its orbit. In orbital mechanics, if you add energy to an object, it moves to a higher orbit. It moves away. So, the Moon is being pushed away from us by our own oceans. Every year, it drifts 3.8 centimeters farther into the dark. It is a slow goodbye, measured in fingernail growth, but over billions of years. It has pushed the Moon from the edge of the atmosphere to a distance of nearly 400,000 kilometers. But nature balances its books. The energy gained by the Moon has to come from somewhere. It comes from the Earth. As the tidal bulge pulls the Moon forward, the Moon pulls the tidal bulge backward. It exerts a drag on the Earth's rotation. It acts as a brake. The friction of the water moving across the seabeds, crashing against the continents, drains the kinetic energy of the planet. The Earth is slowing down. The day is getting longer. We can see proof of this in the fossil record. There are ancient corals, hundreds of millions of years old. that have daily growth rings, just like trees have annual rings. By counting these rings, geologists can calculate how many days were in a year in the distant past. In the Devonian period, 400 million years ago, a year lasted 400 days. The day was only 22 hours long. Going back further to the time of the first bacteria, the day was barely 10 hours long. The moon has stretched our time. It has given us the 24-hour rhythm that governs our biology. Our circadian clocks, the sleep-wake cycles of every animal, are tuned to a frequency set by the recession of the moon. We are living on lunar time. This interaction does more than just lengthen the day. It stabilizes the planet. The Earth spins on a tilted axis, 23.5 degrees relative to the Sun. This tilt creates the seasons. When the North Pole tilts toward the Sun, it is summer in the north. When it tilts away, it is winter. This cycle drives the migration of animals, the growth of plants, the patterns of weather. But why is the tilt stable? Why doesn't the Earth wobble like a dying top? Look at Mars. Mars has no large moon. Its two moons, Phobos and Deimos, are tiny captured asteroids with almost no gravity. Because Mars is alone, its axis is unstable. Over millions of years, the tilt of Mars wanders chaotically. Sometimes Mars stands upright, with no tilt at all. The seasons vanish. The poles freeze. The atmosphere collapses onto the ice caps. Sometimes Mars tips over by 60 degrees. The poles point directly at the Sun. The ice caps melt instantly, flooding the planet with vapor while the equator freezes. It is a climate of violent, unpredictable extremes. Life, if it ever existed there, would struggle to adapt to a world that keeps changing the rules. Earth is different. We have a stabilizer. The moon is large, 1/80th the mass of the Earth. This is huge for a satellite. Its gravity acts like an anchor or a gyroscope. It grabs the Earth's equatorial bulge and holds it steady. It limits the wobble. It keeps the tilt locked between 22 and 24 degrees. It ensures that the seasons are predictable. It ensures that the tropics stay tropical and the poles stay polar. This stability is the foundation of the biosphere. It allowed life to evolve complex strategies, hibernation, migration, deciduous leaves that rely on the climate being roughly the same next year as it was last year. Without the moon, Earth might be a chaotic world of shifting ice sheets and baking deserts, hostile to civilization. We owe our predictable calendars to the silent companion. The moon also drives the mixing of the oceans. The tides are the heartbeat of the sea. Twice a day, the water rises and falls. This movement does more than just wet the beach. It stirs the nutrients. It pulls cold, rich water from the depths and brings it to the shallows. It flushes out estuaries and bays. This tidal mixing helps drive the global ocean circulation, the conveyor belt that moves heat around the planet. It keeps the oceans oxygenated and fertile. And it created a specific habitat, the intertidal zone, the place between the high water mark and the low water mark. This is a harsh environment. Creatures here must survive being submerged in salt water and then exposed to the drying sun and wind every single day. It forces adaptation. It forces resilience. Many biologists believe that the intertidal zone was the testing ground for life's invasion of the land. It was the training camp where fish learned to breathe air and crawl on mud. The moon teased life out of the water. It lured us onto the shore. There is also a chemical theory, the wet-dry cycle. To form long chains of DNA or RNA, the molecules of life, you need to link simple molecules together. This usually releases a water molecule. In a bucket of water, this is hard to do. The water breaks the bonds as fast as they form. But in a tidal pool, the water evaporates. The chemicals get concentrated. They dry out. This drying promotes bond formation. Then the tide returns, re-wetting the pool, mixing the new molecules. Billions of years of tides, wet, dry, acted as a pump for complexity. The moon may have been the chemist that stitched the first genes together, but the moon is also a visual spectacle. There is a cosmic coincidence that we are privileged to witness. The sun is 400 times wider than the moon, but the sun is also 400 times farther away. This geometry means that in our sky, the sun and the moon appear to be exactly the same size. Half a degree of arc. Because of this perfect match, we can see total solar eclipses. The moon can slide in front of the sun and cover the disk precisely, blocking the blinding photosphere but leaving the ghostly atmosphere, the corona, visible. This is the most dramatic sight in nature. The sky turns purple. The stars come out in the day. The black hole of the moon is ringed by the pearly fire of the sun's crown. It has terrified and inspired humans for millennia. It taught us geometry. It helped us measure the solar system. It confirmed Einstein's theory of relativity by bending starlight. But this coincidence is temporary. It is a fleeting moment in geological time. In the deep past, the moon was closer. It would have blotted out the sun and the corona completely. In the future, as the moon continues to drift away, it will appear smaller. In about 600 million years, the moon will be too small to cover the sun. Total eclipses will cease. There will only be annular eclipses, a ring of sunlight surrounding the dark moon. We are living in the golden age of eclipses. We are the only species that will ever see the corona dance around the lunar rim. The moon is also a mirror. It reflects the light of the sun. Its surface is dark gray. It has the reflectivity of worn asphalt. But because the sun is so bright, the moon shines with a brilliance that illuminates the earth. Before electricity, the moon was the only way to travel or work at night. The harvest moon allowed farmers to bring in crops after sunset. The hunter's moon illuminated the forest. Our calendars were born from its phases. The word month comes from moon. The first mathematics was likely counting the days between full moons. It taught us to count. It taught us to predict. But the moon is changing. It is geologically dead, but it is not static. It is still being bombarded by micrometeorites. Tiny grains of dust moving at cosmic speed slam into the surface, pulverizing the rock into a fine powder called regolith. This powder covers the moon like gray snow, meters deep. It softens the landscape. It rounds the edges of the ancient craters. It is the dust of deep time. And the moon shrinks. As its core cools completely, the moon contracts. This shrinking causes the crust to buckle. Lobat scarps, cliffs hundreds of meters high, form on the surface. The moon is wrinkling like a drying raisin. These shifts cause moonquakes. They are small, but they can last for an hour, ringing through the dry, cold rock. The moon is still settling into its final rest. As we look at the moon tonight, drifting among the clouds, we are seeing a partner that is slowly letting go. The tether of gravity is elastic. It stretches, but it does not break. The moon will never truly leave us. Before it can escape completely, the sun will evolve. In 5 billion years, the sun will swell into a red giant. It will expand to swallow the inner planets. The drag from the sun's outer atmosphere will catch the moon. It will spiral back inward. In the final moments of the Earth's life, the moon might return to the embrace of the planet, torn apart by tides to form a new ring, just as it began. Ashes to ashes, ring to ring, but that is the end of the story. We are in the middle. In the next and final chapter, we will look at the human connection. We will look at the moon not as a rock, but as a destination. We will explore the Apollo missions, the moment when life from Earth reached out and touched its companion. We will see the footprints in the regolith that will last for 1,000,000 years. We will reflect on the overview effect, looking back at the Earth from the lunar surface and realizing our own fragility. For now, imagine the tides rising and falling on the shores of the world, a rhythmic breathing of the ocean. It is the heartbeat of the gravitational bond. The moon is pulling on the water, and the water is pulling on the moon. Rest in that rhythm. It is a cradle rocking in the dark. You are held by the Earth, and the Earth is held by the moon. The system is balanced. The night is calm. We have watched the moon, born from fire, coalesce from a ring of debris and cool into a silent white companion. We have seen it recede from the Earth, slowing our day and stabilizing our seasons. But the story of the moon is not just a story of rock and gravity. It is a story of longing. For 4.5 billion years, the moon was a destination that could not be reached. It was a light in the sky, a god, a calendar, a mystery. It was the untouchable. Every human who ever lived looked up at the same face, the gray lava seas, the white cratered highlands, and wondered what it was. It pulled on our imaginations just as it pulled on our oceans. It inspired our first mathematics as we counted the days between phases. It guided our ships at night. It defined our months. It was the mirror in which we saw our own potential reflected. And then, in a blink of geological time, the distance was closed. The creature that evolved in the tidal pools created by the moon learned to leave the water, then the land, and finally the atmosphere. We built machines of fire and metal to climb the gravity well. We reached out across the void. In 1969, the silence of the moon was broken, not by a meteor, but by a voice. Imagine the journey of those first travelers. They left the blue, vibrant Earth and traveled for 3 days through the absolute black of cislunar space. As they moved away, the Earth shrank. The moon grew. It transformed from a flat disk of light into a 3-dimensional sphere of rock. They saw the craters in high definition. They saw the mountains casting long, sharp shadows across the plains of the Sea of Tranquility. They saw a world of absolute desolation. Magnificent desolation, Buzz Aldrin called it. When the Eagle landed, it kicked up the dust of eons. This dust, the regolith, had been undisturbed for billions of years. It had lain there since the late heavy bombardment, ground into a fine powder by the rain of micrometeoroids. Now, it settled on the gold foil of the lander. Stepping onto the surface was stepping into a different physics. The gravity was 1/6 that of Earth. A person weighing 80 kilograms felt as light as a child. They moved with a slow, bounding grace, floating between steps. But the most striking thing was the sky. It was black. Even though the sun was shining brightly, blazing with unfiltered intensity, the sky was an endless, deep void. There is no atmosphere on the moon to scatter the light, no blue dome to hide the stars. You stand in the sunlight, but you look into the infinite dark. The horizon was wrong too, because the moon is smaller than the Earth. The horizon is closer. It curves away sharply. It feels like you are standing on a small peak. Even when you are on a flat plane, you feel the curvature of the world beneath your boots. And the silence of the moon is absolute. Sound needs air to travel. On the moon, there is no medium. A hammer hitting a rock makes no noise. A rocket engine firing is silent. The only sounds the astronauts heard were the hum of their own life support systems, the static of the radio, and the sound of their own breathing. It is a stillness that Earth never knows. On Earth, there is always the wind, the hum of insects, the distant rumble of the ocean. On the moon, the silence is heavy. It is the silence of deep time. But as they looked out at this gray, dead world, they saw something else. They looked up, and there, hanging in the black sky, was a marble of swirling blue and white, the Earth. It was the only thing in the sky with color. It was vibrant, fragile, and alive. It looked like a jewel wrapped in black velvet. Attachment. This view changed us. It is called the overview effect. Seeing the Earth from the moon made us realize that we are one. From that distance, you cannot see borders. You cannot see wars. You cannot see the divisions of politics or religion. You see only a small, fragile biosphere, shielding life from the cold void. The moon, our ancient companion, gave us the gift of perspective. It showed us our home. We went to the moon to explore it, but we discovered the Earth. The astronauts left footprints in the regolith. Those footprints are still there. Because there is no wind, no rain, no biology to disturb them, they will remain for millions of years. They are more permanent than the pyramids. They are more permanent than the mountains of Earth, which are slowly worn down by erosion. Unless a meteor strikes that specific spot, the boot prints of Neil Armstrong will last longer than the human species itself. They are a monument to the moment when life reached out and touched another world. They also brought back rocks, 800 pounds of lunar basalt and anorthosite. These rocks were the keys to the history we have just explored. By analyzing the chemistry of these stones, we learned about the collision with Theia. We learned about the magma ocean. We learned that the moon is the daughter of the Earth. The rocks told us the story that had been hidden for 4 billion years. But the Apollo missions were brief. We visited for a few days, and then we left. The moon returned to its solitude. The equipment left behind, the descent stages, the flags, the laser reflectors, sits quietly on the plains of the Sea of Tranquility and the Ocean of Storms. They are artifacts of a brief summer of exploration. But the moon is waiting. It is not just a museum, it is a stepping stone. The water ice we found at the poles, the legacy of the comets, is a resource. It can be melted for drinking. It can be split into oxygen for breathing and hydrogen for rocket fuel. The moon is a gas station in the sky. Its low gravity makes it the perfect harbor. It is 22 times easier to launch a rocket from the moon than from the Earth. It is the gateway to the rest of the solar system, to Mars, to the asteroids, to the moons of Jupiter. We will return, not as visitors, but as residents. We will build bases in the lava tubes, protected from the radiation. We will set up telescopes on the far side, shielded from the radio noise of Earth, to listen to the whisper of the early universe. The moon will become a second home, a sister world. The relationship that began with a collision will evolve into a partnership of habitation. But for now, the moon remains what it has always been, a silent watcher. Think of it tonight. Imagine the light of the sun hitting the lunar surface. It is a harsh, blinding light. The shadows are ink black. There is no twilight. The surface heats up to 100 degrees Celsius in the day and drops to minus 170 degrees at night. It is a world of extremes. And yet it is peaceful. There is no weather. There are no storms. There is only the slow, steady movement of the sun across the black sky, taking 2 weeks to rise and set. The Earth hangs in the sky, fixed in place. It spins, displaying its continents and oceans, its clouds and storms. It goes through phases, new Earth, full Earth, just as the moon does for us. It is a view of breathtaking beauty, a blue marble suspended in the dark, glowing with the reflected light of the sun and the faint city lights on the night side. This bond is unbreakable. Gravity binds us. We are a double planet system, dancing around the sun together. The moon pulls on you right now. It is a tiny force, imperceptible to your senses, but it is there. If you were standing on a scale, you would weigh a fraction of a gram less when the moon is overhead. It is lifting you up. It pulls on the fluids in your body, just as it pulls on the oceans. We are made of water, and we are subject to the tide. As you lie in bed, visualize the line of gravity connecting you to the center of the moon. A silver thread stretching through the roof, up through the atmosphere, across the vacuum, landing on the dusty plains of the lunar surface. You are connected to that silent world. You are part of the system. The moon has watched over the Earth for 4.5 billion years. It watched the first bacteria form. It watched the continents crash together and break apart. It watched the ice ages come and go. It watched your ancestors looking up in wonder. And now it watches you. It is a symbol of endurance. It has been battered, melted, frozen, and scarred, but it remains. It shines. It reflects the light of the sun into the darkest hours of our night. It teaches us that even after the greatest violence, the collision of worlds, something beautiful can emerge. A new balance can be found. The ring of fire became the silver sphere. The chaos became the orbit. Let your mind drift to that quiet surface. Imagine sitting on the edge of a crater looking back at home. The silence is wrapping around you like a blanket. The stars are steady and bright. The Earth is sleeping. The moon is keeping watch. The cycle continues. The moon moves away centimeter by centimeter, but it will never leave us completely. We are bound by the history of our birth. Rest in the gravity of that bond. Rest in the light of the companion. You are safe on the Earth, held by the rock, watched by the moon, drifting in the starry sea of the cosmos. Thank you for listening to Dreaming Through Knowledge. May your sleep be deep, your dreams be peaceful, and your night be filled with the gentle light of the moon. Good night.